If you follow this step-by-step tutorial, by the end of this video, you will create this box by yourself. As an example, we will use ESP32 board, but you can easily change the box dimensions for your own board. So, let's start. We will be using Fusion 360 with personal license, which is free. Download and install it. Go to Fusion 360. I'm going to double check what kind of units we are using. We would like to use millimeters. Go to default view. I'm going to create new component. We would like to create 3D model of the board. Okay. Be sure it is active. Create new sketch. Select the plane where we would like to draw the sketch. And we are going to add some parameters. So first I'm going to add board width, and we need to search for ESP32 dev kit dimensions. Go to images and maybe use this. So the width is going to be 27.9 millimeter. Be sure units are in millimeters. 27.9. Okay. We would like to also add board length, and again double check on our board. It's going to be 54.4 millimeter. Okay, make them favorite. Okay, now create a rectangle from center, draw it maybe like this, start writing board width, press tab, board length, enter. Right now this rectangle can be moved, and we would like to make some relationship between the rectangle and the 0, 0 position. So I'm going to use this left click. Okay, we still can move the rectangle up and down, so I'm going to use also this left click, okay, and now this is exactly what we would like to have. Save it. I'm going to use default project. Okay, now we are going to add a few components like this module, USB connector and LED. So this is going to be super simple 3D model of ESP32 board. Add a rectangle, put there this number, okay, 18 and 25.5. And again, we would like to specify relationship. We would like to have it here. Next, rectangle from center. This is going to be USB. Put there 7.8 and 6.7. And again, we would like to have it somewhere here. So I'm going to specify relationship like this. And we would like to put here offset because the USB connector is a little bit longer than the board, 1 millimeter. Now the LED, it's somewhere here, and use 0.8 and 1.6. Okay, we would like to place it here, 8 millimeters, and here 13 millimeters. You can measure all these dimensions on a real board. I just make it a little bit nicer. If you move sketch like this, you can use this button to go to the default view. Almost done. Okay, this looks nice. We would like to add more parameters, so I'm going to add module height. Again, measure it 3.4 millimeter. Now USB height 2.7 millimeter, and also the LED. So LED height and 0.7 millimeter. You will see later how these parameters are used. One more parameter, PCB thickness, default 1.6 millimeter. Okay. Finish the sketch. Go to default view. We are going to create the PCB. So select all these. Use this feature, put here PCB thickness, minus PCB thickness. Okay. Make the sketch visible. We would like to draw the model of the module and also add LED. Just specify the height of the LED. Here specify height of the USB connector, and USB connector goes also a little bit down, so I'm going to put here like minus 0.2 millimeter, so it looks like real USB header or USB connector. Perfect. So this is very simple 3D model of our board. Save it. And if you see it like this, then go to inspect and use these colors. I always use it because you can very nicely see different components in your PCB. I'm going to add a few more parameters again. So tolerance small, 0.1 millimeter, and tolerance big, 0.3 millimeter. This is used in multiple places, that's why we use it as parameter, and you can adjust this later. Also add wall thickness on sides, 3 millimeters, then wall thickness on top and bottom. This is going to be 1 millimeter. Okay, and we will use these parameters to create the box. Be sure whole project is active. Go to default view. Now hide the board. We are going to create sketch, and we are going to create some basic dimensions of our box. So use this rectangle, and we would like to specify the size of the box to be board width plus 2 times tolerance big. So this is going to be inside of the box, okay? We also need to specify the length, again, inside of the box. Board length plus 2 times tolerance big. So we need to be sure we can fit there the board. That's why we use the tolerance big. Now move it like this. And again, we are going to specify relationship between the board and zero position. Do it like this, okay? Our board is exactly starting from the 0, 0, so we would like to have the box around the board like this, okay? Double check. Box has to be around the board. Now, I'm going to use this offset feature, and I'm going to put here minus wall thickness sides. Okay. Finish the sketch. Now we are going to create new component. I'm going to call it bottom, and we are going to create the bottom part of our box. So first add parameter box bottom height. Let's say it's going to be 9 millimeters. Okay, now be sure the bottom component is active. Select everything in the sketch. use the extrude feature and go down by minus bottom or box bottom height. Okay, we also need to make the hole inside of this, so select it, use minus bottom height plus wall thickness top and bottom. Be sure cut is selected, it's cutting only through the bottom, and we have very simple bottom part of our box. Now create the top part, very similar. Be sure it is selected or it is active. Add new parameter which will specify the box top height. We can use like 7 millimeters. Okay. Now hide the bottom part. Again, select the sketch, go up with everything. Okay, and make the hole inside. So select this, go up to box top height minus wall thickness top and bottom. Be sure cut is selected. Okay. Okay. So this is the board, and we have this like very simple top and bottom part of our box. Okay. Now we would like to see what is inside, if everything fits perfectly. So I'm going to create this analysis. And next we would like to make the opening for the USB connector. So let's do it. Be sure main project is active. We are going to create sketch on the front panel of our box. We are going to project where the USB connector is located. So now in our sketch we can see the location of the USB connector, and we are going to make opening. So I will use this offset feature by minus tolerance small. The opening is going to be a little bit bigger than the USB connector, and we are going to make one more opening for the plastic around the USB connector. So use like 3.5 millimeter offset. Now enable the sketch, select the opening, and we are going to extrude this up to wall thickness sides. Be sure we are cutting through top and bottom. Okay, now the hole should go through top and bottom completely. Select this bigger opening. We don't want to go through completely, so just put there wall thickness sides, but also at like 0.8 millimeter, and it will look like this. Okay, so the first hole goes through, the second one is second one doesn't go through. It's for the plastic around the USB connector. We need some support, something what will hold the PCB inside of the box. So be sure the bottom part is active, because that's what we are going to work with. We are going to draw a sketch on the bottom of our bottom part. I'm going to enable and disable everything like this. Draw a rectangle, and we would like to place it somewhere under the PCB, in the middle of the PCB. So use these like 15 and 30, and specify the relationship like this. We would like to place it into middle. So it's going to be board length divided by 2. Okay. Make it nicer. Finish sketch. And we need to put it up to the bottom of the PCB. So put there something like this. Okay, box bottom height plus PCB thickness plus tolerance small. Ok. Now double check how it looks. Use analysis, and okay, this looks really good. So there is support just under the PCB. We would like to add also some support on the top of the PCB where the module and USB connector is. So be sure the top is active. We are going to do sketch on the top of our box. And again, add a rectangle. One is going to be like 10 by 10 millimeters. I need to make it visible. And the other one is going to be smaller, let's say 5 by 5. This one is going to be about the USB connector. Now specify the relationship, so we would like to have this one in middle and also this one. And the USB connector is going to be like, let's say 3 millimeters from the edge of the board, and this one is going to be like board length minus, I don't know, 15 millimeters. Make it nicer. And finish sketch. Create 3D model. So we would like to extrude this. It's going to be minus box top height. Be sure you select join. And we would like to make it a little bit shorter. So plus module height plus tolerance small. Okay. Do very similar also for the USB. So select it, use extrude up to minus box top height. Be sure you select join, and plus USB height plus tolerance small. Okay. Double check if it looks correct. Perfect. So now the PCB is not going to float inside of the box. It has support from the bottom and from the top. Perfect. Make the whole project active and double check our box for different board sizes. So I'm going to use, for example, 37.9 millimeter, and everything was adjusted correctly. So this is super useful because if your box or if your board has a little bit different dimensions, you can very easily change these dimensions here, and the box will automatically adjust the size. Okay, super cool. This looks good. I'm going to put it back. 54 and 27. Perfect. Save. Now we would like to improve the box, so we are going to make a rim around the edges of the box. So I'm going to use this offset feature. You will see how it looks when it is finished. So wall thickness, use exactly this, okay? And also put that this. When it is finished, you will see what we are doing. Okay. And I'm going to add one more parameter, rim height. It's going to be 2 millimeters. Now we are going to modify bottom part of our box. Select this and this and extrude down by minus rim height, and be sure cut is selected. Okay. Nice. And now we need to make the top part a little bit bigger. So select it or be sure it's active. Now select this, and distance is going to be again minus rim height, and it looks like this. Oh, this is something wrong, so we need to correct it. In timeline, I'm going to select the places where we created the opening for the front panel for the USB connector, and just move them, okay? Move them after we created the rim. Now everything is correct. Okay, and now you can see what we have created. So this is the rim. To be sure, this will make us sure that the top and bottom always fit perfectly and they are aligned together nicely. Okay, I'm going to add new component, latch, because we have to find a way how to connect top and bottom together, and we will use this latch for this. So we are going to draw a sketch and do it like this. Okay, just approximately, we will add dimensions in the next step. Approximately draw it like this. This is going to be only half of our latch. Specify the relationship. I need more parameters. Latch bottom width. Let's say it's going to be 7. And also latch top width. This one is going to be a little bit more, 10. And we will use these numbers in number of different places. That's why we create them here. And also latch lock distance, and it's going to be 8 millimeters. Okay, now we are going to use these parameters to create the latch. So this is going to be latch bottom width /2. I need to move it a little bit. Oops. Like this. Okay. Now this is going to be half of the latch top width. Okay. I'm going to add also filament diameter parameter. I'm using 1.75 filament, and I also need latch hole diameter, which I'm going to calculate based on the filament diameter, and I will add some tolerance, let's say 2 times tolerance big, so the hole is a little bit bigger than the filament, and we are sure the filament can be fitted inside of the hole. I'm going to create arc, so this is going to be the hole for the filament, Again, later you will see how this hole is used. This is going to be half of the latch distance, and this is going to be the latch hole dimension, diameter divided by 2, because this is radius. Okay, and also we would like to be sure there is also like 1 millimeter wall between the hole and the edges of the latch. Okay, this is going to be 100 degrees. This is going to be like 1 millimeter. Almost finished. This is going to be again half of the latch lock distance, and put there also this. Just use 4 millimeters. Perfect. So this is half of our latch. I'm going to add latch thickness parameter 1 millimeter. We can finish sketch. Let's make 3D object from this. So I'm going to use latch height thickness divided by 2. Okay, and we are going to create second half of the latch. So I'm going to use mirror feature and mirror based on this, and okay. So this is the latch which we will use to connect top and bottom of our box together. We need to specify the place where we would like to put them. We would like to put them on sides of our box. So I'm going to first specify a latch count on side, and this time I'm going to use no units. So this is just a number which will, when the box is very big, we would like to use more latches so we can easily change it. And also we need to add few more parameters which will help us to calculate the position of the latch. So just do it exactly how I'm going to do it here. Okay, again later you will see how this is used. It's so complicated because when we change the number of latches on the side, when the box is very big and we need, I don't know, 3-4 latches, then we always have to calculate the position of the latch, and this is what will help us. Again, use exactly same numbers what I'm using here. Okay, now just place a point somewhere, and now we are going to use the dimensions what we just specified. So here is going to be a latch Y position, and this is going to be latch X position. Again, this is automatically calculated based on the box size and based on the number of latches what we will use. Make it nicer, finish sketch, and we are going to move the latch to this position. So I'm going to use this join feature. I'm going to move it from here, and I would like to move it here. Perfect. Cool. Add this special plane because we would like to see, we would like to do analysis in this place. We would like to see how the latch is placed on the side of the box, and this is how it looks. We would like to make openings for this latch, so what I'm going to do, I'm going to adjust this sketch. I'm going to add a rectangle, put here like latch thickness plus 2 times tolerance big. So we would like to make the hole a little bit bigger than the latch. and a little bit longer than the latch. Okay, and I'm going to specify the position of this opening. So this is what we need to create the openings. Finish sketch. And we are going to draw the opening in the top part of our box. So I'm going to select the rectangle what we just created, and we are going to make the hole. So use the extrude feature, two sides, and do it like this. Okay, what do you think what is going to be the size what we need? Okay, maybe something like this, and also here is going to be the rim height. Be sure we cut only through the top. Okay, double check how it looks. Perfect, so it cuts through the rim and also inside of the box, and we would like to see if it fits around the latch. Okay, perfect. So we can place the latch inside of the hole. We also need to create opening for filament, which is going to secure the latch in the top part of our box. So I created this sketch, and I'm drawing this circle. I need to make it visible. And I would like to place this circle exactly in the place where the hole of the latch is. So specify the relationship like this and put here the dimension. This is going to be the latch lock distance divided by 2. Okay, if we specify this correctly, the circle should be exactly where the latch hole is. So I'm going to extrude this, and I'm going to make the hole okay. Now double check if it's correct. It looks good. Again, later you will see how this is used. We need to create more openings for more latches. So I'm going to use this pattern feature, and we would like to have or we would like to use this spacing, and here we would like to know what is going to be the quantity, latch count on site, and distance is going to be, we need to calculate it. So board length divided by the latch count on site. We would like to have these openings also on the other side of our box, so I'm going to use this mirror feature and select features, the features where we were creating the hole in the opening. So press Ctrl, select these features on timeline, and it should look like this. Okay, perfect. Okay, so we only draw this once, and then we just use this mirror and pattern features to make them around the box. We also need to make opening in bottom part of our box for the latch. This is going to be a little bit more complicated, so I'm going to make the bottom part active, and we are going to draw on this sketch, so just double click there I'm going to create a rectangle, and the side is going to be like this. Okay, use same numbers what I'm going to use. This is the thickness of the opening. This is the length. And I'm going to create one more rectangle because there are going to be two different openings. And again, use these dimensions what I'm using here. So this is the thickness, and this is the length of the opening. I'm going to place them into the correct place. So latch X and latch Y, and the second one is easy. I'm going to make this a little bit nicer. Okay, and second one we just use this relationship, place it into middle of this first rectangle. Okay, finish sketch, and we are going to make the openings. So I'm going to select this, use the extrude feature. We would like to go through the whole bottom height, and we would like to cut only through the bottom part. Okay, and also select this, and this time we don't want to go through the whole box. I'm going to use this. Okay, do it like this. Okay, we would like to cut through the bottom. Now double check what we created. Perfect. So this is how it should look. We need to create openings around the box. So I'm going to use pattern and do it like this. Okay. We would like to use pattern this way and also this way. Use spacing here, just two, one side and the second side, and the distance between them is going to be latch X multiplied by 2, and here is going to be latch count on side, and this is going to be calculated based on the board length divided by latch count on site. Okay, perfect. This looks really cool. Okay, very nice. Again, double check what will happen when we change the parameters. I'm going to make this favorite, and also this one and this one. And let's play with these numbers. So let's say we would like to have 3 latches. Ah, it works! Let's say we would like to make this a little bit bigger, and also change this. Maybe also change this bottom height and top height. Everything is automatically calculated and everything looks okay. See, the support is correctly adjusting, the holes for the latches are adjusting correctly, top is adjusted correctly, and also the board size is adjusted. So this is why, again, this is why these parameters are super useful. And when everything is designed correctly, then using this box or adapting this box for PCB with different dimensions is going to be super easy. Okay, I'm going to put this back to 2. We don't need 3, it's a very small box. 2 are just enough. And I'm going to put all the dimensions back. Okay, save everything. Now we are going to make it easier to separate top and bottom. Also, we are going to make a small hole here for screwdriver. So again, we would like to work with top, and with this sketch which we already have here, I'm going to create a rectangle which is going to be the opening for the screwdriver, and I'm going to move it. So I'm going to specify the distance from here up to here. It should be exactly in the middle of the box, and I would like to move it down. So I'm going to again add dimension, and this distance is going to be, do you know what this is going to be? Rim height. Okay, finish sketch and make the opening. So I'm going to enable the sketch, and we are going to make the hole. So select this, use extrude feature, and it's going to be wall thickness, sides divided by 2, and this is how it looks. Okay, so this will make it easy to open the box. We would like to have it also on the other side. So what I'm going to do, I'm going to very simply move this mirror feature at the end, and I'm going to add this opening inside of the mirror feature. Okay, perfect. We are going to add opening for the LED. So I'm going to work with this sketch on the top. Create circle a little bit bigger than filament, and place it above the LED. So I would like to see where the LED is located, and I'm going to project the middle of the LED, and I'm going to move the circle there. Okay. I would like to also create this offset, let's say 2 millimeters. Finish. And I'm going to make hole inside of the, or in the top of our box, and I'm going to create the guide for the filament. So we will fit clear filament inside of this hole. It will be placed above the LED, and it will very nicely guide the light from the LED to the top of the box. Again, you will see when this is finished. Perfect. I'm going to double check if position is correct. Yeah, it looks good. Also add the filament, so new component. This is not really necessary, but when we will be creating the box, we would like to know the length of the filament which we need to cut. So I'm going to create this also as a component. It's a very simple component. Just I'm going to draw circle, place it again above the LED. So project middle of the LED, place this circle which will become filament, place it above the LED, and now use the extrude feature, and we would like to have this pipe, this light guide, we would like to have it, or we would like to start it just above the LED. Like this. Okay, double check again everything. Perfect. If you don't have clear filament, it's fine. You don't have to put it there, but it looks very nice with the clear filament. If you don't like the colors, you can always change them. We are going to make the box nicer. Be sure we are working with whole project. Select all these edges. We are using this fillet feature, which will make the corners rounded. It looks much nicer now. And we can do something similar also with these corners for the USB opening. So use fillet, select the edges in the opening, and use 1 millimeter. Okay, nice. This is too thin. When I 3D printed this box, I found out the holes are visible on the side, so I'm going to make these sides a little bit thicker, 1 millimeter thicker. When you have a look now, the wall is a little bit thicker, so the hole is not so visible when the box is 3D printed. And also we would like to add text on the top of our box. So I'm going to edit this sketch on the top, create text, just draw it like this, let's say ESP32, but you can use any text you like. I'm going to use this Arial black in the middle, rotate by 90 degrees, and we are going to specify dimensions because we would like to place it exactly in the center or in the middle of the box. So I'm going to specify these dimensions, and we are going to also specify the position. So use the relationship, place middle of this, place it exactly here. Okay, it's not locked. It means there is something still not specified correctly. It looks like this. So I will use this special constraint, and now it's locked. Perfect. Finish sketch. I would like to see it. Select the text and let's say we would like to put it down by 0.5 millimeter. Cool. It looks very nice. We are going to make it even nicer. So I'm going to create new component. I'm going to call it letters. And be sure it is active. We would like to create sketch, and this is very important. Create sketch at the bottom of the embossed letters. Okay, we are going to project the letters. Oops, this one is not selected, so I'm going to project it again. Okay, so now I'm going to hide everything, and I'm going to use this offset feature and make it a little bit smaller. So the letters are going to be a little bit smaller than the opening in the top box lid. So when we print these letters, we can very nicely glue them inside of these openings. Okay, do it for all the letters. Be sure the opening is smaller than the letters. P is a little bit special because we have to do it for this, and also don't forget about this. Okay, and also do it for the numbers. And one more. Perfect. Finish sketch. Select everything and extrude by, I don't know, 1 millimeter. Okay. Cool. So now you can 3D print these letters with different color, for example, or you can just paint them and then glue them on the top of the box. I changed the color to yellow, so it looks nice. Double check if there is space between the letters and the top of our box. We need to be sure that we correctly created these letters. It looks good, it looks okay. Everything looks fine. This looks fine too. And yeah. So this is the bottom part of our box. This is the top part of our box. This is the latch, letters, light guide or light pipe, board, and the bottom. We are going to double check if everything will work correctly when we change size of the box. So the letters are always in the middle. LED light is always in the correct place. Latches are fine. Cool. Looks like everything is adjusting correctly. Okay, so double check if your box is also adjusting correctly. If you did everything same way as I did it here in the video, everything should work. Perfect. Save. It's done. We are going to 3D print it, so I'm going to export this bottom part of our box. I'm going to export it as STL. Export. And I'm using this Cura. Okay. We would like to 3D print also the top. When you 3D print it, don't forget to clean everything. Again, I'm going to export this as STL. And put it inside of Cura. We would like to 3D print also the letters. So export the letters. And same way also export the latch. We can print them together. So I will place the latch and letters inside of Cura. That's it. That's everything for this tutorial. I really hope you design and build your own box and you like it. If yes, fantastic job. Well done. Now, you know everything important about how to design your own box. However, if you would like to learn how to design your own boards, check out our online courses. You can find their courses for beginners and professionals where you can learn how to design boards from very simple ones like Arduino or a power supply up to courses designing boards with processors, memories or high-speed interfaces. Have a look, just go to fedevel.com. Okay, don't forget to leave your comments and let me know if you like this tutorial. Thank you very much for watching and see you next time. Bye!